Okay with that?
So now,
Okay, Alan. This is really describing positive slope situation. 45 miles per hour. Okay, so what's the practical meaning of on the right? I get 5x minus what? Step formed, and with what would I have to do to both sides? Add 7. Where are you going to be then? Exactly where we thought we'd be. 5x plus 2, right? Now, one thing I want you to pay special attention to, a lot of the things that we do in here are going to be consistent with function form. So instead of leaving that as like y equals, you're probably going to want to say that this is f of x equals, yep. So guys, this is the condition right here for writing a parallel line to 5x minus 7. I'm going to jump into Desmos here real quickly. You guys have the work down that I've got here?
Tissue box.
There's, oh gosh, actually, that would be a great job for you, KP. What? Run down to the office and get a a tissue, couple of boxes of Kleenex for us, would you? You know, your own little lanyard. It's like metal. Run down and get those quickly, okay? Thanks, kiddo. All right, so here's what I want you guys to do. You just make sure we're kind of confirming our work here. If I go into this and I say, well, by Desmos, what was the original equation that we were given? Was it 5x minus 7, kids?
Yeah.
5x minus 7? So I'm going to type in 5x minus 7. There it is, right there. All right? And we said we had to come up with a line that was parallel to that, didn't we? Passing through which point? Okay, so we know we have to have a line that's parallel to that travels through the point 1 comma 7. So let me get this up here on the graph. There's my point 1 comma 7 that we're working with relative to that given line. What equation did we come up with that was parallel there? 5x plus 2. Quick question. Parallel, green and red parallel there? Okay. Pass through the point that we wanted to pass through. A good visual of the work that we've got there. Okay. So what I want you guys to do on your own here, try this on your own. I want you to do the next one. Same concept, same exact concept, but instead of being parallel to this line, I want to pass through the same point, but rather be perpendicular, or this should say perpendicular to your line, 5x minus 7. So I want you guys to take a minute, maybe talk it over with a partner around you if you get stuck, bounce some ideas off each other, but see what you come up with there, okay?
No, but I realized my mistake. It was a simple. Yeah, kind of. That's.
Okay, guys, talk to me about the slope. Originally, this line 5x minus 7 has a slope of 5, so if I want to go perpendicular to that, what slope do we have to consider here?
Negative 0.2.
Okay, the opposite reciprocal of 5 would be negative 1/5, right? And we're still traveling through which point, kids? Through the point 1 comma 7. So I'm going to go ahead down here and I'm going to look at point slope form again and say, all right, well, if I go y minus y1, my y1 value is, so we're going to write this as y minus 7 equals negative 1/5 times the quantity x minus what? Okay, so I'm gonna distribute on the right. I end up with negative 1/5 x plus 1/5. Guys, talk to me about getting y alone. What are we doing?
Add 7 to
That's 7,
the
so I've got y equals what?
negative 1/5 plus 7 1/5, or 36 or 5.
Okay, and I'm just gonna leave it as a mixed number, 7 1/5. And I like what you have there. If you were quizzing or testing, I said, yeah, that's good. You get it. You know the process. But again, if I wanted to get technical, talking about function form, how would you express this?
F of x.
Yeah, f of x equals negative 1/5 x plus 7 1/5. Okay. How many had that? I'm curious. Or a form of that. Anybody call it 7.2 or anything like that? All the same? All good with
I
that?
had 7.2.
That's fine. 1/5 is 0.2, 2/10, so all good.
Yes,
Okay.
thank you.
All right. Any questions so far up to this point? Not too bad, is it? Just kind of coming back to you, kids? Coming back to you? All right. Well, let's see what we can get ourselves. Oh, I like this example right up here. Now we'll kind of start looking at some of these here that I want to do together here. I like this problem right here. So suppose you're driving from Minneapolis to Des Moines, a distance of how many miles?
146.
So about 113 miles from Des Moines, you pass through Clear Lake. Sketch a graph of your distance from Clear Lake as a function of time. Okay. Let's just do this. It's basically saying you're 113 miles between where and where, kids? Des Moines and
Clearly.
Clear Lake. Okay, so what I'm going to do is this. Let's just pretend we're thinking about this. Minneapolis up here. Clear Lake is in between Minneapolis and Des Moines. And what was the distance between Minneapolis and Des Moines in that problem again, kids? 246 miles.
Yeah.
It said, I got to read this again one more time. It says about 113 miles from Des Moines you pass through Clear Lake. So that would imply there's 113 miles from Clear Lake to Des Moines. Would you agree with that? Okay, about 113 miles from Des Moines, you're in Clear Lake. So, okay, here's what this is saying, kids. This is saying there's how many miles between Clear Lake and Des Moines?
113.
So my question becomes, could we find the distance between Minneapolis and Clear Lake then? What is that value?
246 minus 113.
Which would be
132. No.
close, 133, right? Okay, I'm gonna come back to this little sketch. I think this puts things kind of in better perspective for us. So if I left Minneapolis, how many miles to get to Clear Lake, kids?
133.
And then from Clear Lake to Des Moines, how many miles to go?
132.
Okay, for our total drive trip of how many miles?
246.
Okay, let's kind of read what's going on here in this example. I like this. It's a great application. It says, sketch graph of your distance from where, kids? Okay, everything is a distance from Clear Lake as a function of time. So we got a distance from Clear Lake as our dependent variable and a function of time. So the distance is measured in what, kids?
Mile.
Okay, so let's just do this. I'm going to draw kind of a first quadrant of an XY axis here. Okay? And what I'm going to do over here on the left-hand side, I'm going to call this distance from Clear Lake in miles. And how do you think your time's going to get measured here, kids? Miles per... Yeah, we're going to measure our time in hours. Is that okay down here? This will be our time in hours. Now, I want you to read this one more time. Anybody have an idea about how I would sketch this graph? Understanding that we're sketching this function as a distance from where? Clear Lake. I want to ask some maybe clarifying questions on this. where are we starting from?
Clearly.
Careful on this. Where are we starting? We actually are starting in Minneapolis and we're going to what? Des Moines. But we're going to base the distances that we are from Clear Lake. So if I go back to maybe this little diagram over here, when we start this problem right here, how far away from Clear Lake am I when I'm in Minneapolis?
133 miles.
I'm 133 miles away, so at time zero, how many miles from Clear Lake are you? Okay. Whoops. So I'm going to say, you know what? When we first start our trip, we are in Minneapolis, which is a distance of 133 miles from Clear Lake. Now, guys, as we start driving, what's going to happen to my distance? Why is it going to decrease? Okay. Let's just assume we're going to drive at constant speed. We're going to set up the cruise at 70 and go. Fair deal? Do I cross that axis or not?
Yeah, because that, wouldn't that be where Clear Lake is?
So
That
you're telling
axis?
me that when I hit the x-axis, that's the time at which we are how many miles from Clear Lake, guys?
0.
Zero.
So this point represents the time where we are where now?
Clearly.
Well, we drive through Clear Lake. What's going to happen to your distance then again from Clear Lake?
Plus
It's gonna
zero.
increase.
It's going to start increasing again, right? Now, guys, when I get to Des Moines, is Des Moines going to have a higher value than Minneapolis, or will Minneapolis have a higher value than Des Moines?
Minneapolis, because Des Moines is only 113.
Yeah, we're only 133 miles to travel. Here we only have how much to travel now? So this graph, should it end above where we started or below where we started? Darn well better end below where we started, right? Okay, so this is how this is going to look to us. Why do I keep doing that? Yeah, and it's going to end up kind of like this. Maybe right about there. Okay. So this point right up here represents we started the trip. We were how many miles away from Clear Lake? Took some time. We're getting closer and closer and closer to Clear Lake until I get to this point right here. This point represents the time at which we are how many miles away from Clear Lake?
0.
You're there. And then once you get through Clear Lake, you start putting distance between yourself and Clear Lake in that vehicle, and you end how many miles away?
113.
Okay. Kids, you have questions about that example at all? A lot of things going on there. It looks pretty simple, but there's a lot of things that you need to take in consideration to model that correctly. Are we good there? Okay, let me shut this down. Why don't you guys get into your books on page